Good afternoon, class. Today we're going to be solving inequalities using cut points. And the natural question is, what is an inequality? Well, an inequality is something that has a less than, a greater than, a less than or equal to, or a greater than or equal to symbol on it. That's something we haven't seen today in the first 4 weeks of the semester. All we've been solving are equations in the first 4 weeks of the semester. But today we're going to solve stuff that has less thans and greater thans in it. And at the end of class on Wednesday, we were trying to review something called interval notation because that's going to be part of the procedure. With interval notation, we have shaded regions on a number line, and how do I want to word it? You'll have open and closed circles at each number. The closed circles mean you're not including that number. The open circles mean you're not including the number. The closed circles mean you're including it. Like right here, this shaded region is all numbers between -5 and 4, including -5, but not including 4. This one over here to the left of -6, it's all numbers to the left of -6, not including -6. And these endpoints we label with infinity symbols, a negative infinity and a positive infinity, right down here. And what we're going to do today to solve these inequalities is we're going to follow that little recipe. Did everyone get a copy of that? The little sheet of paper, the handout?
Okay.
Let's see, they're right there.
I'm going to put them right here.
Okay.
And that handout is under Files on Canvas. If you're like me, going to lose that sheet of paper, it's under Files on Canvas.
What happened to the handout? Oh, here it is.
There it is.
Okay, there it is. And this little recipe, what we're going to do is draw a number line. Label numbers on the number line. We call those cut points. Get me one of those so I can just be using the sheet of paper rather than flipping back and forth. And this. Okay, so the first 2 steps here tell us how to find these numbers on the number line that we call cut points. They tell you how to find them and then how to label them with open or closed circles. The 3rd step, you draw the number line and label those cut points in numerical order. It's going to be crucial that you have those numbers in numerical order. And then the 4th step tells us how to decide which regions to shade and which regions to cross out. We're going to be choosing a number in each interval and plugging it in. And then the last step, express the shaded intervals using interval notation. That's what we were doing here. At some time in your algebraic life, you saw interval notation, but unless
probably
you used
have
it
to
a lot,
type it in. You'd have to type it, but
and it was, it's so easy you forget it. The easier it is to learn, the easier it is to forget. Use square brackets for closed circles, parentheses for open. Always use parentheses for infinity symbols. Wow, is it just me or is this printout not very dark?
it's not very dark.
Oh, okay. Well, let's go ahead and do problem number 1.
I was going to say, we need to see a problem, work through it, and
problem 1.
oh no, that's the test when I was, okay, go back. Here, let's find it. We're going to do problem number 1.
Write it down. And just like that student said, you got to sort of pay attention to the instructions. This idiot teacher told him to study the instructions. Solve the following inequality. An inequality is what you call one of these things that has a less than or greater than symbol in it. And then also the instructions actually say type your answer using
let's see.
interval notation.
Type your answer using interval notation. I'll tell you right now, I was never that fond of interval notation. I preferred the inequality notation or writing it out in words, describing the set of writing it in words, but
that's not conducive for stuff like this. Mm-hmm. So we're now going to be looking at the little recipe and go through these steps.
Okay, let's look at the first step of that little recipe. Where is it?
Tim, just here.
Oh, okay, that's so dim.
Okay. That's not my fault. Y'all have your own? If you can't see this, you have another sheet of paper that's real dim and you can't read? Okay. First thing we're going to do is we're going to find what's called the solution cut points. There's two types of cut points, solution and denominator. To find the solution cut point, you replace the inequality symbol, that's this greater than, replace it with an equals and solve for x. So I'm finding the solution cut point. I'm just going to abbreviate that first step like that. We're solving x squared minus 17x plus 66 equals 0. Well, now it's an equation, and that's what we've been solving for the first 4 weeks. This is a quadratic equation because there's an x squared, so either factor it or use the quadratic formula.
It didn't say use the quadratic formula in the instructions, so
pretty certain.
I've already factored it in my head, so I'm 100% certain it's factorable. So let's try to factor it.
A simple trinomial because there's not a number in front of the x squared other than the invisible 1. The second sign is plus here, so what sort of signs will we have in the factored form?
2 negatives.
2 of the first, so 2 minuses. So I'm going to draw my 2 sets of parentheses and write x minus. What sort of numbers multiply together to give us 66? Here's my thoughts over here. 1 times 66, 2 times 33, 3 times 22, and there's another one.
6 times 11.
I'm thinking 6 times 11. Is 6, well, I was about to ask. I've picked out the one that's going to work. Which one's going to work here? The 6 and 11. The two numbers need to add together to give us 17. So if we put 6 and 11 here, oops, 6 and 11. If you FOILed it out, we'd have x squared, then a minus 11x and a minus 6x combined to give that minus 17x. Then negative 6 times negative 11 is positive 66. So I've factored it correctly. Now set each one of these factors to 0. And we get x equals, what's my first solution cut point? X equals 6 and x equals 11. Okay. Now, the note on both of these first 2 steps tells you how to decide between open and closed circle. I'm wondering if y'all can read through that note and figure out what the heck I'm saying. If the problem contains less than equal to or greater than or equal to, use a closed circle. If the problem has just strict less than or strict greater than, use an open circle. What are we saying we're going to use for these?
An open circle.
An open circle. I'm going to make a note of that right now. And we're now ready to move on to step 2. In step 2, we're finding what we call the denominator cut points. It can also be called domain, but for right now, let's call them denominator. and it's abbreviated DCP, denominator cut points. Set any denominators that are not equal to 0 and solve for x. What you're doing is finding where the stuff is undefined. Are there any denominators?
Show them the problem. Let them see.
Do we have any denominators in this problem?
When I wrote the problem, when I saw that problem, I knew we'd skip over number 2. In order to have number 2, in order to actually do number 2, you have to have what appearing in your inequality. Okay, you skip number 2 if there's no fractions in the original problem. And there are no fractions, so step number 2 we're going to skip.
I'll make a note, though. No denominator cut points. You know what I'm going to say? Because there are no fractions.
Good idea.
Now,
you know, you should put a little 1 there. That's step 1. This is step 2.
but in viewing examples, sometimes they do the denominator cut points before the solution cut points.
I'm just going by the
There's nothing that
instructions, by
okay.
our recipe.
Okay. Now step 3, draw a number. Okay, you're right. I'm going to label. Step 1 is in green. Step 2 is in, I think it's brown. Now, step 3, we draw a number line and label those cut points. Make sure you put those numbers in numerical order. I'm even going to label the arrows as negative infinity and infinity. So the only numbers I'm labeling on here are the cut points. We have 2 solution cut points.
Which one's going to go first?
6.
The 6 goes first. Remember, it goes small to big.
And open circle. Keep in mind that if we're going to get these right, you're going to have a number line drawn. It's looking pretty good, right? Looking sort of like this one here, except we have 2 open circles. And now we need to shade some of these regions.
Let's read step number 4.
Select a number in each interval and substitute it into the original inequality. If the inequality is true, shade the interval. If the inequality is false, cross out the interval.
That's how we're going to get the shaded intervals and the crossed out intervals. If the inequality is true, looking at this first interval here, a number to the left of 6. What's an easy number to the left of 6? You could use negative 1 million, but that's not an easy number. What's an easy number?
But number's always between a negative and a positive.
0. If 0 is a cut point, you can't use it as a test value, but it's not a cut point. And so that's the number. 0 is the number I like to use. What about between 6 and 11? Give me a number there. I'll let you. We could use 6.734928, but use something easy. Use an integer. What do you want to use?
7, 8, 9, or 10.
We're going to have to square it. 10 is easy to square. I can square
10.
You could use 9, 8, 7. You could use 7.5. If it's true at 10, it'll be true at 7.5. It cannot change from shaded to unshaded without either being equal to or not be a number. This method is asking, okay, where is the left side equal to the right? Where is the left side undefined? Anywhere else, it either has to be less than 6 or greater than 6. Greater. 0. Less than 0 or greater than 0. They can't switch from less than to greater than without either going to through the equal possibility or the undefined possibility.
Okay, now a number between 11 and infinity. Heck, we could use 1,000,000. I'm going to use 12.
Okay.
Now you test by plugging into the inequality up here. So plug in up here into the thing that the original problem. 0 squared would be 0. Minus 17 times 0 is what? Still 0. Plus 66 is greater than 0. Y'all see what I'm doing? I'm plugging 0 into the original problem, the inequality.
Oh, this is step 4.
Oh, yes, step 4. So on the left, 0 minus 0 plus 66, is that just going to be 66? Is greater than 0?
True or false? True. So we shade the interval containing 0. Suppose we had plugged in 1. Suppose we'd plugged in 1 instead of 0. Would we get true or false?
Still true.
Suppose we plugged in pi, 3.14159. Would we get true or false?
Still
Any
true.
number to the left of 6. If you plugged in negative 50 million, it would still be true. Every number to the left of 6 makes that a true inequality. What about between 6 and 11?
Well, let's see. We chose 10.
Mm-hmm.
Let's plug 10 in. 10 squared is 100. Minus 17 times 10 is 170. Plus 66, oh, I didn't leave enough room, is greater than 0. So let's see, what do we have here? 100 minus 170 is a negative 70. Plus 66, negative 70 plus 66, is that a negative 4? What do y'all think about that? True or false? False. A negative number cannot be greater than 0.
Cross it out.
Now, let's plug 12 in. Y'all caught up with me? 12 squared is 144.
144.
Minus 17 times 12.
Nice.
Thinking of 12 is 10 plus 2. 17 times 10 is 170. 17 times 2 is 34. 170 plus 34, is that a 204?
Yes, it is.
Plus 66 is greater than 0.
I bet you everyone used their calculator there. 144 minus 204, that's a negative 60. Plus 66, that gives us a positive 6 is greater than 0. True or false? True. So we shade. Any questions on the testing step? Last step. Look, put the little instruction there. We're ready for step 5.
Which what we were doing in the class the other day.
Now we're ready to write that shaded interval and interval notation. So,
okay, so always put, step 5, write an interval notation. You're writing it for the shaded region, not for the one that you crossed out, the true regions. So it's negative infinity, comma 6. Always put parentheses by infinity symbols. That's a parentheses, not a square bracket. And open circles are parentheses. Okay?
So every number to the left of 6 makes that a true statement. Or, and denote or, we use a stylized set union symbol. It looks like a U. You'll find that on the toolbar, okay? Now, y'all call out this right-hand interval as if you were typing it in. What would you do? What would be the first thing you type in for this interval? Open parentheses or left parentheses? 11.
Comma infinity.
And what always goes after a positive infinity? always use a parenthesis in front of a negative infinity, always use a parenthesis after a positive infinity.
Brand new purple ink isn't working. Okay. Oh, still. And that's what you got to type in.
Okay.
Remember years ago, an employee here in the math department saying, she doesn't understand. I don't understand why this method works.
Method of yours.
This method of yours works, but it does work. And I was like, oh yeah.
I was surprised by that. To me, it may not be clear to y'all,
But it makes perfect sense.
Where is it equal? Where is it not a number? Anywhere else, it has to either be less than or greater than. And the real number system is dense. We can't switch from less than 6 to greater than 6 or less than 20 to greater than 20 without going through the number 20 itself. Oops. Late. There. Notice the parentheses come from the keyboard. When we have a bracket, the brackets will come from a keyboard also.
Not the toolbar.
Right. And I should have mentioned this also. There's only one infinity symbol on the toolbar. I'll get the emails. Oh, there's no negative infinity showing up for me. That's right. There's no negative infinity key. For our purposes, you have to
hit the little minus.
Hit the little minus and then click the infinity symbol. Now, you know something, Tony? Do we have time?
No, we don't.
Oh, okay.
I'm going to look back at this. Usually you don't have to test every interval. Okay? The intervals, they usually alternate. Do y'all know what I mean by alternate? If the first interval is true and it alternates, what would y'all guess the rest of them are? The first one's true. False. True. Does this alternate? Yes. The intervals might, don't you love that word in math? The intervals might not alternate if you have repeated factors.
Now, suppose the expressions are linear. You don't even have to factor it, okay? Suppose that we'll see some problems where there are no x squares to begin with. Then you can rest assured they're going to alternate. If you test one interval and it's true, the one beside it is false, and so on. And this is a huge deal because it'll save you from having to check every one of those intervals when you're going through the process.
I said that they might not alternate if you have repeated factors. What do I mean by that?
If this is factored as x minus 6 times x minus 6, you need to check every interval. If you had added x minus 11 into x minus 11, you need to check every interval.
If you get the exact same thing in both sets of parentheses when you're doing trial and error to factor something, you better check it. But if you don't need to factor it, then it's going to alternate. If you do factor, but you get different stuff in the parentheses, then then it alternates.
So once we did this 0 and knew that was true, I would have bet every set that I have that the next interval will be false, and then true. Now, for me, the easiest number, my favorite number to plug in is 0. And it should be obvious why. If you're plugging in a 0, the terms containing x are disappearing. Notice how easy that was there.
0 squared, 17 times 0.
So what I'll do is I'll draw the number line, then I'll locate 0, and that's the interval I'll test.
No, Tim, I was joking earlier when I said, no, we don't have time. You said, do you have time?
I was going to actually work one with repeated factors. I have a real easy one. But, okay. It'll only take a second. Gosh, I don't want this to be timed out, though. If y'all want to see one that doesn't alternate, yes. I'll make up one that's real painless for us.
Paper down.
Okay. Here. Example. X squared minus 10x plus 25 is less than 0.
Ooh, that's going to be, no, greater than.
Okay.
Oh, okay, yeah, you were, okay. Then maybe it's less than.
Okay, first step, looking back at our little recipe, you set it equal. X squared minus 10x plus 25 is equal to 0.
It's perfect. Not really good.
Okay, and then we can factor this. X squared is x times x. What do we know about the signs? Okay, the second sign's a plus, so you have two of those first signs, minus, minus, and 25. You can have a 1 times 25, or what's the other one? 5 times 5. It's a simple trinomial, so you can choose the pair. You need the pair that adds together to give you what? 10. So we're using 5 and 5.
Do we have repeated factors now?
We have repeated factors. The same thing inside there. So it may not be an alternating situation. We're going to have to check every interval. But this isn't that bad because set x minus 5 equal to 0. What are we going to get as our solution cut point? Setting this x minus 5 equal to 0, aren't we going to get the same thing? So we only have one solution cut point. How are we going to label this cut point on a number line?
Look at the first note.
There. Oops. Look at
with an open circle.
Oh, okay. There's just a less than or greater than. There's no equality, so we'll use an open circle. What do we conclude about step number 2?
Are there any denominators?
No.
There are no denominators. There are no fractions in the original inequality, so there are no denominator cut points. Good. Third step, we draw our number line and label the cut point.
Well, there's only one cut point.
The cut point is 5, and we said it was going to be an open circle. Step number 4, we have to check intervals, but since there were repeated factors, we can't assume an alternating pattern, okay? We have to check each interval individually. We need a number to the left of 5. What's an easy number to plug in? 0, good. At the end of class today, you'll be able to tell people, I can locate 0 on a real number line.
That's
regardless
my joke. At the end of the semester, when someone says to you, well, you took Mr. Precella's algebra class. What can you do now? What did you learn? You can say, I can locate 0 on a real number line. And that's a joke, okay? Hopefully you can locate 0 way before, but when there's a lot of negative cut points, students have trouble figuring out where 0 is sometimes.
What about a number to the right of 5? You know what I'm going to use?
10.
What number is easy to square there? 10? I think I'll use 10. You could use 6. You could use 7. You could use 57, but I'm going to test 10 because it's easy for me to square. I can do the arithmetic in my head then. So, testing 0. 0 squared is 0 minus 10 times 0 is plus 25. Is that less than 0? No, that says 25 is less than 0. So
cross it out
And label it false.
and label it false. Now let's test 10. 10 squared is 100 minus 10 times 10 is 100 plus 25 is less than 0. So this says 25 is less than 0 also. True or false?
False.
So we cross that one out, label false.
Let me look at these answers. When you're doing the homework, for something like what he just did,
There'd have to be a,
on some of them, I think they might have an option for.
They do.
Oops, wait. What's the answer going to be? No solution or empty set. See if everything's false.
there's no shaded intervals, so I don't suppose that happens in the homework, but still, when you have repeated factors, all sorts of weird things could happen.
You might get true.
You may get true. And here's the funny thing. You know what causes these funny things like this, the non-alternating? It's the same thing that causes those imaginary numbers, the even exponents. X minus 5 times x minus 5 is the same thing as x minus 5 squared. And when you're squaring something, regardless of what the sign is on the inside, when you square it, what result are you going to get?
The number squared.
You're going to
will
get a
be
positive result. It's the way even exponents change negatives to positives. It's that same problem that we had with square root equations that caused us to have to check our work. It's the fact that those even exponents are taking negative stuff and changing them positive.
But for our purposes, go back there. If there's no factoring at all, then it alternates. You know what? Maybe you should even write no repeated factors. Alternate.
No.
And hopefully
Repeated.
it's clear what we mean by repeated factors. That x minus 5 times x minus 5. You get the same thing in both sets of parentheses.
And you say, well, how is that going to save me work? What's the next one we're going to do, Tony?
Problem 3.
Problem 3. Okay. Let's do problem number 3.
X times x minus 4 is less than or equal to 12.
Okay, this is number 3. Let me write it down. X times x minus 4 is less than or equal to 12.
Oh, you see? There. I knew they start giving you this option.
Oh, there
this
it is.
empty set. Okay.
There it is. So there is an option if something were like that were to happen where it wasn't alternating and maybe nothing checked. Although I'll tell you right now, if that were to happen, you
better
need to check your work. There's a
It's
greater
never happened
likelihood
before.
that you messed up than that empty set situation appears. I don't recall it ever occurring in the homework. Okay, so here we go. How do I know that I have to use the cut point method? How do I know?
Yes.
What do I see here that
Do
says?
the instructions say use the cut point method? No.
That is how we're going to solve what? Inequalities. If it's an inequality, that's when you use the cut point
But
method.
if it doesn't say inequality, it still says write it in interval notation, so that's a hint. And if it has a less than or a greater than or a less than equal to, greater than or equal to, you sort of got to pay attention to these instructions. Okay, so let's do this.
First step. Hey, when I'm looking at my little cut point recipe, I wonder if you focus it again, would that make it clearer?
I will focus it again. But when I look at the sheet of paper, it's not that clear to me.
That's
It's
why I
so
said just
dim.
switch back to Chrome and show
But,
it.
okay.
And then bind it up there.
Okay.
Okay, when you look at those instructions, there's one step we're going to skip for number 3.
which of the steps will we skip? 1, 2, 3, 4, or 5? 2. There are no fractions in this problem. So it's just like number 1, we're going to be skipping that denominator cut point situation. We'll find our solution cut points, make the inequality equal. Go ahead and switch now. Hey, this is already factored on the left side. For a moment, you think to yourself, this is great, but if you're going to solve by factoring, what number do you need on the other side?
Not a 12.
The 0, and we don't have a 0. So this factoring they've done right here is actually just a hindrance. It's just extra work for us because we have to undo it. Distribute the x to get x squared minus. Distribute the x to get x squared minus 4x. And then what do you think I'm going to do with this 12? Move it over to the left and get it set equal to 0. And then we can factor. I'll write my 2 sets of parentheses. I can already tell we're not going to get the same thing. That's one thing, the point that I didn't make. If you're going to get repeated factors when you're factoring, this number here has to be a perfect square. 12 isn't a perfect square. It's not like this one here. 25 was a perfect square, so you were able to use 5 and 5. That gave you the same thing inside the parentheses. But here, 12 isn't a perfect square. There's no way you're going to get exactly the same thing inside the parentheses, so we're not going to have to check every interval once we get to that step. We have an x and an x. Hey, what do we know about the signs? I forgot to ask you all that. I couldn't hear you.
Oh, signs, you can have a positive and a negative.
A positive and a negative. I'll wait to fill that in until we've decided on the numbers that we're going to use. For 12, either 1 times 12 or 2 times 6 or
3 times.
3 times 4.
But which pair is going to work?
Which pair will we use? You want the pair that subtracts to give you what number? The 4? Which one of these will subtract to give you 4? The 6 and the 2? Now play it out in your head. We need 1 plus and 1 minus. What are we going to put here? If we put the plus in front of the 6, is that going to give us back the minus 4x? Or do we need a minus in front of that 6? I agree. The minus in front of the 6 and then a plus. So let's just verify. First, x times x, that's x squared. Here's my scratch work I'm checking. Outer, x times 2 is 2x, positive 2x, okay. Inner, what are we going to get? Negative 6x. Last, negative 12. 2x minus 6x gives us, that's the correct factorization then. Set each factor equal to 0. X minus 6 equals 0, means x must equal 6. Set x plus 2 equal to 0. That means that x needs to equal negative 2. And these are my solution cut points. How will I label those solution cut points?
Negative 2.
Okay, I might label negative 2 and positive 6. You're right.
In that order, you're right. But now he wants to know open or closed circles.
Close, because the inequality has an equal to possibility. These numbers make the left side equal the right side. Inequality is okay here, so we have to use closed circles on those. So we found our solution cut points. Any questions? We found our solution cut points. And the second step, there are no fractions in the problem. So what did we say we do? Just skip that step. Third step, we have to draw our number line and label the cut points. And remember, they go small to big, so -2 goes first, and then +6. And we're going to, we said they'd be closed in circles. Can we assume an alternating pattern, or do we need to check every interval? You can assume an alternating pattern. We got different factors inside the parentheses. So I'm 100% confident it's going to alternate. That means it's either going to be true, false, true, or false, true, false. Well, let's decide which one. What's my favorite number to test? 0. And notice 0 isn't a cut point, so we can test 0. Where's 0 located? Is it to the left of -2? Is it between -2 and +6? Or is it to the right of +6? It's to the left. Wait a minute. Where is it?
To the right of -2?
Yes,
okay,
it's to the right of negative. It's between -2 and +6. So this is step number 4. We're going to test 0.
If this interval is true, then
what will we assume
cross
here?
these out.
Oh, you already told me.
No, if these are false, then we'll shade the other ones.
Right. Okay, so we're going to test 0. Plug 0 into the original problem. We'll have 0 times, what are we going to get inside those parentheses? 0 minus 4 is -4. Is that less than or equal to 12? 0 times anything is 0 is less than 12. True or false? True.
It's not equal.
So
but
what do
it's
we
less.
do here? It's true. Shade or cross out? Shade. So let's say we tested -3 or -10. What would happen over here to the left of -2? Shade or cross out?
We're going to cross out.
We'd cross it out. If we tested -3 or -4 or -50, they'd all be false. What about to the right of 6? Suppose we tested 7, 8, or 50 million. True or false?
False.
False as well. So, fifth and final step, interval notation. How many intervals are we going to do we have in our solution?
One.
Just one, so we're not going to have to use that union symbol from the toolbar. Am I going to start with a parenthesis or a bracket?
A bracket.
A bracket, because -2 is shaded. We have a bracket, -2, comma, right hand endpoint, 6. What will go after the 6? Parentheses or bracket, because it's closed in. This is called a closed interval. An interval that starts and ends with a bracket is called a closed interval. And why is it called a closed interval? Because it starts and ends with closed circles.
I wonder, like, something with 2 parentheses is called an open interval. Okay? So you can have open intervals and closed intervals.
Or you can have it open at one end and
closed
closed
at
at the
the
other end.
Okay, let me type this in.
For these brackets, you use the keyboard. There's not a special symbol in the toolbar.
Maybe if you went more, there might be something. But why
You
would
should
want to
never
do that?
have to use more.
More.
You should never have to use more on that toolbar. Click that more button just for them to see what pops up.
Okay, that's a lot of stuff.
Mm-hmm.
I'm going to say less because I don't want to see all.
Okay.
-2 to 6.
Mm-hmm.
Any questions there?
It's a nice little recipe. Okay, it's long, but eventually I'm going to tell you the method that our teacher used the first time we ever saw these. Okay? And it wasn't the cut point method. When I saw the cut point method the first time, I was like, oh wow.
Why weren't we shown this?
Yes. Instead of the method we had. But let's go on to number 5.
Okay.
Oh, well, wait, you're showing the...
Well, I just wanted to ask him, are we, okay,
Well,
we're calling those steps. Let me write down the problem to number 5, and then we've been skipping step number 2. My question is, are we going to skip step number 2 in this problem? Let me write it down. 2x over x plus 3 is less than or equal to 3. Oh my goodness.
2x over x plus 3 is less than or equal to 3. You did it.
So, in the past, we've been skipping over step number 2. Are we going to be able to skip over step number 2 here? No, because we see that there are fractions there, that x plus 3 in the denominator. We're going to have to take into account when is that fraction undefined. But let's just follow the little recipe. The first thing we do is find our solution cut points. 2x over x plus 3. We replace that less than or equal to with just an equal to. There's the equation we need to solve. What do you think I'm going to do to solve this equation? I'll give you a hint. Look at what I'm doing there. What do you think I'm going to do?
Cross multiply.
Cross multiply. That's right. That's what I'm going to do. I'm going to cross multiply. 2x times 1 is 2x equals 3 times x plus 3. What are we going to have to do with that 3 and the x plus 3? Starts with the d. Not divide. Distribute. 3 times x plus 3 gives me a 3x plus 9. 3 times x is 3x. 3 times 3 is a plus 9. Are we going to have to factor this?
No.
Do you see any exponents in the original problem? All the factors are linear. So you don't have to worry about repeated factors. No matter, there'll be a denominator cut point, but we'll know that there's an alternating pattern. And I'm always relieved when I realize that we only have to check one interval, okay? But it's not quadratic. I think I'll move the 2x over and combine it with that 3x. What am I going to get? If I move that 2x over, what am I going to have?
A 1.
3x minus 2x gives me 1x. Let's take this 9 and move it over. What's that going to give me?
A negative 9.
A negative 9? So there's my first solution cut point.
The only solution.
My only solution cut point. X equals negative 9.
Look at the symbol to decide between open and closed circle.
Look at the symbol. We're going to have an open circle or a closed circle at that solution cut point. You look back at the original problem, there's equality. Negative 9 makes the left side equal the right side. Is equality okay? Is it okay for the left side to equal the right side? Yes, so that's why you're using a closed circle. You're saying negative 9 will make the left side equal the right side, and that satisfies the inequality. Step number 2. The general process for the cut point method. You ask yourself, when is it equal? The next thing you ask yourself is, when is it undefined? Well, we're spelling out here in this second step. With a fraction, you know when it's undefined. A fraction is undefined when the denominator is 0. So your denominator can't be 0. Set that any denominators that appear, that's a not equal to. It's hard to see that. Not equal to 0, and solve for x. So x plus 3 cannot equal 0.
solve for x as if that were an equal sign. We know how to get x by itself. What do we have to do to get x by itself? Okay, move the 3 over, so we're going to get x cannot equal negative 3. There's my denominator cut point. Look at that recipe. Look at that handout I gave you. And remember, this handout is under Files on Canvas. Always label denominator cut points with an open circle. You never want a denominator of 0. If you tried to plug in negative 3, you get negative 6 over 0. That's undefined. So for denominator cut points, it doesn't matter what the inequality is. You always use an open circle. Any questions on our logic? For the solution cut points, you have to look back at the original inequality. If there's equal to, closed circle. If there's no equal to, then an open circle. But for denominator cut points, it doesn't matter what that symbol is. You never want the denominator to be 0, so you always label denominator cut points with open circles.
So it changes it? If we have a denominator?
If we have a denominator, it doesn't matter that there's equality. You use an open circle.
For the denominator.
For denominator cut points, always open. Third step. What's the third step?
Draw the number line.
Draw the number line. I'm glad you know that, Tony. I was going to see
Maybe
if
label infinities on the
I
number
will.
line also.
I need to. You need to be reminding me to do that. That's one of those good practices I never did. So sometimes I forget to
Here's
do it.
when you think, oh my gosh, my math teacher's an idiot. He thinks we don't know how to put numbers on a number line. Just make sure you put them in numerical order.
What's going to go first?
Negative 9 or negative 3? Which one's closer to negative infinity?
Negative 9. Remember, small to large. You have to make sure you have the numbers arranged in numerical order.
And
how will I label negative 9? Open or closed?
Closed.
Closed, I agree. Negative 3, how will I label that? Open. We said you never include denominator cut points. There was no repeated factors. There weren't even any exponents appearing anywhere in the problem. So I'm 100% confident that it's going to be an alternating pattern. Either true, false, true, or false, true, false. Well, how do we decide which one? Step number 4, what do? You choose a number and test. What number do you think I'm going to test? 0. Which interval contains 0? Interval 1, 2, or 3? 3. 0 is to the right of negative 3.
0 is always between a negative and a positive. It'll never be between two negatives
Or 2 positives.
And here what we have is two negatives. Nope, right here, negative to positive. That's why I told Tim label the infinity so you see there's a negative and a positive. That's where 0 lies. Remember years ago a student asking, why does 0 move around? And it was like, 0's not moving around. It's the cut points that are changing. 0's always where it is, between a negative and a positive.
I'll see people put a little tick mark and label 0 the number they're testing. I think that's a bad practice because invariably that 0 starts popping up in final answers. Look at how we've been typing these answers in. Well, we tested 0. There was 0. Did you type a 0 in your final answer? So my advice to you, only label the cut points on the number line.
The cut points are the only numbers that can be in your answer.
Those are the only numbers that can
Not the
appear.
test
Your
point.
test value, you test 0, but do you type 0 in the answer? Look at this one. No, where's that first one that Tony did? Here, he tested 3 different numbers, 0, 10, and 12. Did you type a 0, 10, or 12 on the answer? No, the only numbers that can appear in the final answer are, or cut points themselves. I'm sorry about that. I forgot to turn off my volume. Oh, goodness.
That makes sense. So you can confuse it when you're alternating between true and false. So that's why you don't want to label it right.
That's right. And so we're testing 0. Let's plug in 0. 2 times 0 is, we're plugging it into the original problem, the inequality. 2 times 0 is 0 divided by 0 plus 3 is less than or equal to 3. 0 divided by 3 is 0. Remember, 0 divided by a non-zero constant? It's okay. That's 0. It's okay to have 0 on top. That's equal to 0. You can't have a 0 on the bottom. True or false? 0 is less than 3. True or false?
It's not equal, but is it less than?
Yes.
Yeah.
Yes, it's true. So what are we going to do? Shade or cross out?
Shade.
Shade. Okay. What about between -9 and -3? Shade or cross out? What about to the left of -9? Suppose we tested -10 or -12. Would it be true or false? True, so we shade. Fifth and final step, what's our final step?
Write it in interval notation.
And I'm going to let y'all call it out as if you were typing it in. As if you were typing that interval notation in. Let's do this first interval from -infinity to -9. What's the first thing I would type? Parentheses. You always put a parenthesis in front of a -infinity. It doesn't matter what the other endpoint is. Look at this blurry handout. Always use parentheses for infinities or negative infinities. Use a parenthesis for open circles. The only time you use a bracket is if you have a closed circle at that cut point. So -infinity, comma. We put a -9. What's going to go after the -9? A bracket. And then what are you going to have to type when you have more than one? Okay, when you have more than one interval in the solution, you type that little U, and once again, that comes from the toolbar. Call it out as if you were typing it in. What's the first thing you would type for this second interval? Parentheses or bracket. Parentheses, because it's an open circle, and then -3, comma, positive infinity. And what goes after the positive infinity? You always put a parenthesis after a positive infinity. You always put a parenthesis after a negative infinity. You only use a bracket at closed circles. Any questions? Oh, and by the way, the infinities come from the toolbar, but there is no negative infinity symbol. I'll get the email from the online classes. Y'all won't do that because I'm telling y'all, but my online classes, I get worried because there's no negative infinity in the toolbar. You have to type the negative from the keyboard. Bracket. Where is the bracket?
Not there.
Oh, it's there beside P. The bracket symbols, if y'all are like us, and we never took a keyboarding or typing class, so we're very slow.
-3,
Comma, infinity.
infinity. When we first saw this, our teacher, her method was, think about it. You sat there and thought, I'm not saying any names.
Oh, okay.
You sat there and thought about it until you came up with the answer. The first time I ever saw this sequence of steps, I was like, oh my gosh,
maybe that's what we were supposed to have been doing, was thinking about it and figure out this sequence of steps. Back then there were these paper books. Why didn't we just open up the paper book and look through that?
Surely they would have had a.
Yeah, they had the
more-
steps out there written in the book. But for us, oh wow, you think about it. You just think about it till you pop out this answer. So let me tell you, the sequence of steps, it might be long, but oh wow.
It sure makes things
Sure,
easy.
it's a repetitive process that always works.
Where is it equal? Where is it undefined? Anywhere else has to be less than or greater than, and it can't change from less than to greater than without going through equal or undefined. It can only change at those cut points. Oh, look at number 4. When I look at number 4, let's just analyze this problem and see if we get an idea of what the answer is going to look like. What do y'all think? Will we have any closed circles on our number line?
Or any brackets in our answer?
Will we have brackets in the interval notation? If there's no closed circles, do you expect to have brackets in your final answer? No. Are we going to have any denominator cut points? Yes, we are. Okay. So this is number 4. Negative 7 divided by x minus 1 is greater than negative 1. Negative 7 divided by x minus 1 is greater than negative 1. Okay. So the first thing we're going to do, replace the inequality with an equal to and solve. What do you think I'm going to do with this negative 1 right there? How am I going to write it?
Over 1.
Over 1, because what am I going to do here? Cross multiply? Yeah, I think cross multiply. Negative 7 times 1 gives me a
Negative 7.
negative 7 equals, over here when we did that, I don't think y'all like the way I just went to 3x plus 9. 3 times x is 3x. 3 times 3 is 9. I can tell y'all were hesitant about that step. So here I'm going to show it. It's negative 1 times x minus 1. Negative 1 times x minus 1. That's a 1. We need to distribute the negative 1 over x minus 1. What's that going to give us? A negative x, and negative 1 times negative 1, I agree, that's a positive 1. Are we going to have to factor this thing?
No.
Are we going to pick up repeated factors? No, because there's nothing that's quadratic. We don't have any exponents, so nothing to factor. So what is that telling me about when I get to the number line? What's that telling me? That you can just do one interval and assume an alternating pattern. To solve for x, I think I'm going to pick this negative x up and move it to the right. That'll give me what? A positive x equals, then what am I going to have to do with this negative 7? Becomes a positive 7. 1 plus 7, what am I getting as my solution cut point? X equals 8. That's my solution cut point. And how will it be labeled? What do I look at? To decide how to label a solution cut point, what do I look at? The inequality, there's no horizontal bars saying equal to, so how will I label it? Not closed,
Oh, sorry.
open circle.
Here's what a student once told me how she remembers it. She thinks about what uses more ink, to write an open circle or a closed circle. Well, a closed circle uses more ink. What about this symbol? What uses more ink? When you have the little line under it or not? Well, when you have the line under it, it uses more ink.
I think that's a good idea, Tony. Because look at, I understand what you're saying, okay? That's a good way of saying it. Because what uses more ink? There's the greater than, or a greater than and an equal to. If they use the extra ink, that means you're going to have to use the extra ink and shade that thing in. That's a good idea, Tony.
Years ago, a student told me that. I said, I'm going to remember that. Maybe y'all don't get what I'm saying. You see what
I
I'm
do,
saying?
Tony.
Oh,
It's Johnny Carson and Ed McMahon,
yeah.
okay?
Before any of y'all were born, there was this man that did a late night TV show, and he had a sidekick, and he'd tell jokes, and no one would laugh, but Ed McMahon would sit there and laugh and stuff, you know. So, but do y'all see if you have to put the little line, it's going to use more ink.
If
So
you gotta
close
fill it in,
the
it's
circle.
gonna- okay.
No line, less ink.
So just an open circle.
Let's
Second
move on
step.
to the denominator cut.
Denominator cut point. Set any denominators that appear not equal to 0 and solve for x. Instead of just saying set the denominator, there may be more than one denominator. I don't know if there is, but if there were, every denominator that appeared, you'd have to set not equal to 0. So the only denominator that appears is x minus 1. We can't let that be 0, which means x cannot equal what?
Positive one.
Positive 1. And denominator cut points, you don't look back here. Denominator cut points, you know.
Like
Always open. If there's a denominator cut point, it is always an open circle. Step number 3. What do we do?
Number line.
Draw a number line. And we have our two cut points. And let's see there, 8 and 1. Which one goes first? Here.
1.
1, it goes small to big. 1 and then 8. And they're both open. We've already said that we can assume an alternating pattern. That means if we're running out of time and this were a test, you have a 50-50 shot. Either true, false, true, or false, true, false.
But if they take the test at home,
They're plenty. I mean, you're not going to be running out of time. You're going to take your time and
go ahead. Wait, where's 0? We're going to test 0.
which interval contains 0? Interval 1, 2, or 3? Wait.
The one. Okay.
0 is always between a negative and a positive. It's not between two positives. It's not between two negatives.
So we're testing 0. We get a negative 7 over 0 minus 1. What's 0 minus 1?
0.
No.
Negative 1.
Negative 1 is greater than negative 1. Negative 7 divided by negative 1 gives me a positive 7 is greater than negative 1. True or false? True. 7 is bigger. That's true. So what are we going to do? Shade or cross out?
Shade.
Shade. And just think about this. This is really amazing when you think about it. It doesn't matter what number you plug into the left of 1. You could have plugged in negative 50 million. You're still going to get the left side greater than the right side. You're still going to get a true statement. I think that's just an amazing feat that we know for any number over here. You plug it in, that's going to make that a true statement. What about between 1 and 8? Suppose I plugged in 2 or 2.5. True or false?
False.
False.
It alternates.
Suppose we chose something like 9 or 10 or 10 million over here. True or false?
True.
True. Fifth and final step.
Right up here.
Interval notation. Call it out as if, am I going to have any brackets in my interval notation?
No.
No, because there are no closed circles. So it's only going to be parentheses. So I'll get it started. Parenthesis, we're doing this interval. Negative infinity, comma, and you've got to type that comma or they're going to count it wrong. The right-hand endpoint, 1, parenthesis. What do I put between the intervals? The U, the union symbol from the keyboard. And now call out this interval to me. Call it as if you were typing it out. Parentheses, comma, infinity, for my final answer.
And if you don't like this, just think about it.
Yeah,
Just think about it. I remember sitting in that class just thinking, what the heck? Yeah. Mm-hmm.
Yeah, so when you tested it with the 0, you plugged in -1 to x.
Well, we plug 0 in for x. 0 minus 1
is
Right.
negative 1. The -7 didn't change. There was no x to plug in there. But we've had -7 on the top. 0 minus 1 gave me a -1. Is that bigger than -1? It's just a coincidence those numbers turned out to be the same.
negative.
And -7 divided by -1 is +7. Any questions there?
So let me type it in. Parentheses, negative.
Notice he typed the negative from the keyboard and then the infinity. There is not a negative infinity key on the toolbar. Then the union symbol, looks like a U,
Comma.
infinity.
Right. Yeah. That's what we've done. 5. Let's do 6.
That looks good.
That's not a 22. It's a Z. Of course, we were being too lucky. Everything had X's. So this is a Z.
Let me write it down. Z divided by Z minus 11 is greater than or equal to 2 times the letter Z.
Are we going to have any closed circles in this?
Yeah.
Yes, because there's an equal sign on there. Are we going to have any denominator cut points?
Yes.
Yes, because there's a fraction.
Okay.
Mhm.
Okay. Oh, did you want to take?
Go ahead.
Step number 1. Okay. Step number 1, we replace the inequality with equal to. Oh, I should have put that as a 2z over 1. Because what am I going to do here? Cross multiply. Z times 1, that's easy enough. Z times 1 is 1z equals, then 2z times z minus 11. I'm going to show that. You have 2z that you're multiplying by z minus 11. Can y'all tell the difference between my 2's and my z's?
Yes.
I'm putting a little bar, those horizontal bars through there for to try to distinguish the z's from the 2's. There's really only one correct next step. What is it? Distribute. I agree. Let's distribute. What are we going to have on the right side? 2z times z is 2z squared minus 2z times 11 is 22z. Uh-oh, there's a square. It's quadratic. We're going to have to factor it. So,
This is a good one because we haven't factored anything like this yet.
okay, this is a good one. You're
At least
right.
I shouldn't recall it.
No, I don't think we have. Okay. The z-squared coefficient is a positive 2. I want it to stay a positive 2. So I'm going to not get the 0 on the right. I'll get the 0 on the left by doing what? Moving that z over by
Okay, minus z. What's that going to give us? We'll have a 0 equals, we have 0 equals 2z squared negative 22z minus an additional z is going to give us negative 23z. And this is the first time we've factored something in this form.
It's a binomial and a trinomial.
Yeah, it's a binomial. There's not that constant term. This is the easy stuff to factor.
To factor out a common factor. Both terms have a z, so what we're doing is we're creating a distributive property. What can we take out of both of those terms? Oh, I said it, didn't I?
Yeah.
I said both terms have a z. I wanted to say both terms have a common factor. The common factor is z. Oops.
This is called factoring a variable out.
We're factoring out a common variable factor. We have 2z squared. So we have 2 z's. We took out one of the z's. What have we got left inside those parentheses? 2z minus. You had a 23z. You took out the z. What have you got left? 23. Set each factor equal to 0. Be careful, there are two distinct factors. The z factor, set it equal to 0. Set 2z minus 23 equal to 0. This one's already solved for z. We have the first solution cut point. What about here? To solve for z, what do I have to do? Move the 23 over. That'll give me 2z equals,
Plus 23.
okay, positive 23, and then divide by 2 to give us z equals 23 over 2. 23 is a prime number. You can't, 2 doesn't go into it, so we're just stuck with 23 over 2 for my second solution cut point. We have two solution cut points. 0, which we got from setting that first factor equal to 0, and 23 halves. How will we label these solution cut points? I'll give you a hint. It's either open or closed. Closed, because there is equality. These will be closed cut points. Second step. Second step. We ask ourselves, when is the inequality undefined? When is that fraction undefined? When the denominator is 0. So we say z minus 11 cannot equal 0. What am I getting as my denominator cut point? Okay. That's my denominator cut point. Be careful. How are you going to label that? Open or closed? Always label denominator cut points.
Say it.
Oh, I did
Say
it.
it again.
How are we going to label?
Open or closed?
With an open.
Open. Always label denominator cut points open. It doesn't matter what the original inequality is. Third step,
We're going to draw the number.
draw the number line. And this is the first time that we have 3 cut points. Hey, I should ask, are we going to have to check every one of these intervals? We did have to factor, but did we get the same factor in both cases? No. We didn't get the same factor. We would have needed a perfect square constant term over here, which we didn't have. We didn't get the same. If you're going to get the same factor, if you have repeated factors, that means you would get the same cut point, like in this example I did over here. No, that's not it. Where? We got the same factor, so we wind up getting the same cut point twice. Z minus 5, x minus 5 equals 0, x minus 5 equals 0. That certainly didn't happen here. So even though we have 3 cut points, we can assume an alternating pattern. Now, okay, be careful. What's the smallest of the 3 cut points? Which one will go first? 0. Now what's next? Are we going to have 23 halves or 11? Which one is smaller? 11 is 22 halves. 23 halves, that's the same thing as 11.5, isn't it? It's 22 would be 11, so that would be an 11.5.
He doesn't see that I've punched it. I'm showing it to y'all on the calculator.
You're right. So be careful. Make sure you put these numbers in numerical order. And we said 0 would be closed. What about 11?
Would be
Open. 23 halves. Closed.
Imagine as a young student and you were just thinking about it and getting the answer. Oh my gosh. Well, I think at this stage of the game you need a sequence of steps.
What's my favorite number to test? I can't use the 0 because 0 is a cut point. Well, in that event, what do you think's a number close to 0 that's real easy to plug in? 1, that was going to be my advice to you. If 0 is already used as a cut point, test 1. Which interval contains 1? Interval 1, 2, 3, or 4? 2. 0 is right there between, 1 is right here between 0 and 11. So I'm going to test 1. I'm going to test 1. And that gives me 1.
So let's plug the 1 in place of the
over
Z.
1 minus 11. I plug in the 1 there. 1 minus 11. What am I going to have here? Negative 10 is greater than or equal to 2 times 1 is 2. True or false?
This 1 over negative 10, that's a negative.
Negative 1/10 is bigger than 2.
And I heard false. Oh.
True or false?
Yeah.
That's false. Oh, something, hold on. I'm doing manual zoom like that. Oh, we're good. Okay, focus again real fast. Put that down and
Okay.
true or false?
They've been saying
False.
false, Kim.
Okay. Y'all know I'm hard of hearing. So what will we assume here if we had tested negative 1? Shade or cross out? Shade, I agree. Suppose we had tested, that's 11.5. Suppose we tested 11.1 or 11.2. Shade or cross out? Shade.
So it's true, false, true.
And what's going to happen here? Suppose we check the number over here. True or false? False, so we cross out.
I think you can write your answers. Oh. Now move it up.
Move it up. Can y'all see it if I write it down here? I like the whole problem to appear on this one page. So, fifth and final step, interval notation. Call it out as if you were typing it in. We'll do this interval first. What's the first symbol you would type? Parentheses, and then
Negative infinity.
remember you always put a parenthesis in front of a negative infinity, comma, right hand endpoint,
0.
parentheses or bracket, bracket. What do I type here? U for union. Now the next interval, parenthesis or bracket, parentheses, because it's an open circle, 11, comma, 23 over, I think it's a 2,
Oh.
parentheses or bracket,
bracket. I want to see you get that just by thinking about it. Let me tell you, this little sequence of steps. I'm a firm believer, I'm an optimist. I believe things can always get worse. And so,
Who was it that told you that that means you're a pessimist? I
yeah.
always look on the bright side. I had a major cancer surgery 5 years ago, and I had to spend weeks with a catheter. And hopefully none of y'all have ever had one of those.
Hopefully
right?
they don't even know what
it
that
is. But no matter how bad a day I have, no matter how bad a day, and I had a lousy day on Wednesday, okay? I don't know if y'all can tell I was annoyed, okay, 5 days ago. At the end of the day, you know what I thought? Well, at least I don't have a catheter, okay? I had a big bag that had to be strapped to my leg, and people didn't know.
I know, but
Well, they are thinking. They're thinking, reading the
don't
recipe.
do this.
Oh.
Y'all do not do what I just did. You see where I put that bracket? You do that, it's going to count it wrong.
And it's not going to say, hey, your format's wrong. So
I got to get right arrow and then the bracket, square bracket. But imagine I'm thinking back to students and that crazy method of thinking about it. You know, I look back at it, and first of all, I think I'm an idiot. Why didn't I look through the book or back in that, 40, 50 years ago, oh gosh, 40? 40 years ago, there were no math labs at all the schools like there are now. There were no tutors you could just go and ask, and they say, hey, here, follow this sequence of steps. Well, anyway, enough of that. Any questions on that? True, it's long.
Oh, it's not that
Not that long, okay? And it's, the sequence of steps, none of the steps are, I guess the first step is the most involved.
Yeah, finding the solution cut points is usually the longest step.
Now, let's move to problem 10. And you'll see why we're jumping there. Let me see.
Number 10. Let's write it down. The
What's
last time.
different about this one? That's not a 17 there.
We have absolute.
It's the absolute values. The last time we looked at how to solve absolute value equations.
And the reason we did that is because the first step to the cut point method is to make the stuff an equation.
Hey, there's absolute value bars here, but are there any fractions? Are we going to have any denominator cut points? No, so you'll skip step 2.
Make sure I don't miscopy. Okay, yes.
Okay.
You need to remember batteries. It's going, oh my goodness.
Is it already dead?
Oh no. Okay. The first step to solve an inequality is to solve the equation. We solved absolute value equations the last time. What is the first step to solving an absolute value?
Always.
Where is it? No. Goodness, we're using a lot of. Where is it?
Oh, there it is.
Always isolate the absolute value bars first. It doesn't matter whether it's an equation or an inequality. You've got to get the absolute values by itself. So what I'm going to do, it's an easy enough matter to get those absolute value bars by themselves. I have to get rid of that +1 by doing what?
Isolating it.
Okay, isolating it. But what am I going to do with the +1 to isolate those absolute values? Okay. So here's the problem. If my absolute value bars are not isolated at first, I'm going to isolate them. Instead of a 7 minus 1, what have I got? A 6. I'm going to isolate the absolute value bars, and then my advice to you, do not look back at the original problem. Get the absolute value bars by itself with the inequality, and then don't look back at the original problem. Pretend this is the problem you were given. Use the cut point method because that's the only way we're going to solve inequalities this semester. Is through, if there's a less than or greater than, less than equal to, or greater than or equal to, we're going to be using the cut point method. So the first step, you set the absolute values equal to 6. I remember solving these things on Wednesday. We have an absolute value equaling a positive number. How many solutions do we expect? What numbers have an absolute value equaling 6? 6 or negative 6. So that stuff there has to be either 6 or negative 6. Do I remember doing that? So you take the stuff on the inside, set it equal to positive 6, set it equal to negative 6. Solving the first equation, I'd move that 7 over. That'll give me negative 5x equals, what will I have here?
13.
Wait, what are we going to do with that 7? That's a positive. When it comes over, it's going to become a... Okay, 6 minus 7 is a negative 1. Any questions on our logic there? We minus 7, 6 minus 7 is negative 1. Any questions in the peanut gallery? If you have questions, y'all need to call out, okay? Because I won't see it if your hand's raised.
Well,
Then what are we going to do?
But unless they're behind the pillar, the big pillars.
What am I going to do to get the x by itself here? Divide by negative 5. That gives me x equals negative divided by negative is a positive 1/5. For my first solution cut point. Now solve this one. Subtract 7 from both sides. That's going to give us negative 5x equals negative 6 minus 7 is negative 13. And then divide by negative 5 to give me x equals negative divided by negative is a positive 13 over 5. For my second solution cut point, how will those be labeled? Closed, because there's equality. So these are going to be closed circles on the number line. Now I remember solving absolute value equations on Wednesday, correct? That's why we solved absolute value equations. We're supposed to solve absolute value inequalities in this course. Well, first step to solve an inequality is to solve the equation. And what do we say about the second step? We're going to skip it because there are no fractions.
Now, even though we're calling second step, we go in that order. The view and example sometimes they find the denominator cut points first, sometimes they find the solution cut points. And if you're a view and example person, which for this assignment I highly recommend against, they don't give any names to anything.
They don't
just have
them
numbers. They don't say the word cut point any time. Just solve it with an equals. Take the denominators, but they never refer to cut points. They're just calling them numbers. I like having these names because by the end of the semester, cut point's going to mean something to you.
So we have 2 cut points to label. Which one do I label first? 1 over 5 is smaller than the 13 over 5. 13 over 5, what is that? That is 2 3/5. So that's definitely bigger than 1/5. And we said it was closed. There was no factoring. We didn't see any x squares. We never had to factor, so we can assume an alternating pattern. So what number do you think I'm going to test? Earlier, y'all wouldn't let me test 0 over here on this one. Can I test 0 here? Yes, I can test 0. Which interval contains 0? Interval 1, 2, or 3? 1, I should go back and say, y'all were right, I couldn't test 0. It isn't that y'all just stopped me, okay? It wasn't like I wanted to do it and y'all stopped me and made me do something else. You couldn't use 0 because 0 was a cut point. Here it's not a cut point. 0 is between a negative and a positive, so I'm testing 0 here. And this is where I'm going back to the rewritten inequality. This is the thing I'm going to test in. I'm going to say use to test. For the testing purposes, it's better if you use the isolated format. There's less chance that you'll make a mistake. So we have the absolute value. 7 minus 5 times 0 is 0. Is that greater than or equal to 6? These are absolute value bars. There and there. 7 minus 0 is 7. The absolute value of 7 is?
-7.
No, the absolute value of 7 is, how many units is 7 from 0 on a number line? It's just a positive 7. We have the absolute value of 7 and the absolute value of 7. How many units away is 7 from 0 on a number line? It's 7 units.
You can have a negative inside the absolute value bars, but once you rewrite it without the absolute, it better just be.
It better not be negative. The absolute value of 7 is 7. True or false? True. So a shade here. True or false?
False.
False. Here. True. Fifth and final step. What do we have to do?
Write out your
Interval notation, okay. Call it out as if you were typing it in. Let's do the left-hand endpoint first. The left-hand interval first. Call it out as if you're typing it in. Parenthesis,
negative infinity,
-infinity,
comma,
comma. And it's bad, but if you forget to type the comma, they're going to count it wrong.
1/5.
1/5. Bracket, because it's a closed circle. What do I write here? Union. That's saying all the numbers to the left of 1/5, including 1/5, or this interval. What do I type first?
Bracket.
Bracket. Left-hand endpoint. 13/5. What goes after the 13/5?
Comma.
Comma.
Infinity. Parentheses.
Good. Any questions there? Left parentheses, negative infinity, comma, 1/5. Get out of that denominator before you type the bracket. Union. Left bracket. 13/5.
Oh my God, wait, 3. Okay, you're right. 13/5.
Get out of the denominator before
You
you
do
put that
this,
comma. They're going to count
Even
it
if
wrong.
you do that and put the infinity in parentheses, let's see what happens. Oh,
You see, and they don't tell you you got the comma in the wrong place. That's why I say never put a comma in a denominator. Okay, let me get rid of that comma. Move right here, put it there. What I just did is 5 on the homework, but on tests you can't be doing that.
Now,
Oh,
the
let me try
homework you
again.
mess up, you
can
can
try
change it,
again,
okay?
or-
But,
Not on tests.
oh, God. Oh, this is a good one. Number 11. And I'm going to have to write small and neat here, okay?
Want me to do it?
Maybe I should. Oh, goodness.
Oh, yeah.
I'm just not a small writer.
I take up a lot of paper.
I think that teacher that gave you all those penmanship awards just had bad vision, and she could see your writing.
It was multiple teachers, and you know that 4 different teachers gave me penmanship awards.
Okay. Wow.
Something so totally worthless now, okay? Well,
X squared plus X minus 25
is greater than 5. Are we going to have any closed circles in our answer on the number line? Are we going to have any rectangular brackets?
No.
No? What's the first step to this problem?
Bring it out of the absolute value.
Okay, so you're going to make it equal. Hey, we don't have to move stuff around. You see the absolute value is already isolated. Unlike number 10, where there was that, what was it, plus 1 stuck there, but the absolute value wasn't isolated. Here, on the plus side, the absolute value is already isolated.
Mm-hmm.
So, oh yeah, you're right. Change it over.
Oh, let me move this up. And I think I'm going to be able to get it done on this sheet of paper. Okay, so to solve an absolute value inequality, to find the solution cut points, the first thing you do is solve it with an equal sign. What numbers have absolute value equal to 5? What's the only numbers that can be in there?
5 or negative 5, I heard it.
Oh, okay. So x squared plus x minus 25 equals 5, or x squared plus x minus 25 equals negative 5. So we set it equal to positive, equal to negative.
And we did the equation here. We did this as an equation at the end of class the last time. We forgot to start back recording.
And I forgot to start recording, so it's not in the
Yeah, I remember I said I'm making up a problem. I looked at the new assignment and hoped that it wouldn't change the numbers when it came time. So we set it equal to positive 5, set it equal to negative 5. That's the longest part of this problem.
What we're doing right here is going to be
the longest part.
Okay, so it's a quadratic equation because we have an x squared. So I need a 0 on one side. So if I move that 5 over by subtracting 5, I'll have x squared plus x. What's going to be right here? Minus 30 or minus 20?
Minus 30.
Yeah. Equals 0. And let's see. Let's try to factor it.
Notice all the factoring we've done today in these problems has been simple trinomials, just x squares. So this program isn't that bad. It's not that cruel and mean. They're not making you factor 2x squared plus 7x minus 24, something like that. It's just x and x. Now for 30, you can have 1 times 30 or 2 times 15 or...
5 times 7.
Okay, it's easy to pick it out because remember it's a simple trinomial. You want the pair that, in this case, subtracts to give you 1, so 5 and 6.
And how should I arrange my plus and minus sign to get a plus x?
A plus 1x.
Negative 5 and positive 6. Y'all agree with me? Foil it out in your head and see. Are we
That's
getting
a
it?
6x minus 5x. That's a positive 1x. So
Set each one of these to 0. So I'm about to get 2 green cut points. Is that positive 5?
Yes.
and what's the second one?
Negative 6.
Negative 6.
And while I'm thinking about it, let me go ahead and decide on open or closed circles. Looking up here. Oops. This was
Just mark that out.
okay.
Mark that out.
Okay.
Open or closed? Are we going to have open or closed circles for this problem?
Open.
Because there's no equality. Are we sure about that? Make sure that he didn't miscopy the problem. No, you're right. Okay.
Now we'll do the same thing. I'll move this minus 5 over by adding 5. So we'll have x squared plus x, negative 25 plus 5. That's going to be a negative what? Negative 20?
It's another simple trinomial.
Let's see. X and x. 1 times 20, 2 times 10. There's another pair.
What's the other one? 4 times 5. Which one are you going to use?
4 and 5.
4 and 5. Because they subtract to give you that 1x that you need. Where are we going to put the plus? Where will we put the minus inside those parentheses? Here.
Negative 4.
Negative 4 and a plus 5. If we FOIL that out, we'd have x squared and then a plus 5x and a minus 4x. That gives me the plus x. And then negative 4 times 5, negative 20. So we factored it correctly. Set each one of these to 0. And we're going to get 2 more cut points.
Here, what are we going to get here? X equals
4.
4.
Move 4 over, so x equals 4. And
Here.
X equals negative 5.
negative 5. And those are all open circles. Do we have any denominator cut points?
No.
There's no denominator cut points. Because there's no fractions. So let me draw a number line. Wow.
While he's drawing that number line, y'all be thinking, how are we going to label those through? Tony's going to put 4 tick marks there. Okay.
4 open circles. Got to put these 4 numbers in numerical order. Which one's closest to negative infinity?
Negative 6.
Negative 6.
And then what?
Negative 5.
Negative 5, I agree.
4.
4. And the last one?
5.
5. Can we assume an alternating pattern?
Yes.
Yes, notice, even though we had to factor it, we didn't get this repeated factors. So we can assume an alternating pattern. That means we can just check one interval. What number do you think I'll use as a test value?
Interval.
0. Which interval contains 0? Interval 1, 2, 3, 4, or 5? 3, I agree.
What's that statement? I say 0 is always between
A negative number and a positive number.
That's how you decide where 0 is. It cannot be between 2 positives. Can't be between 2 negatives. So I'm testing this interval. And that's going to decide the alternating pattern. But be careful when you do this testing.
If you're only going to check one interval and assume an alternating pattern, it's essential that you check that one interval correctly. Because if you think it's true and it turned out to be false, then everything else is wrong.
So let's plug a 0 in. 0 squared is 0. Plus 0.
Minus 25
Minus 25.
is greater than 5.
No, here, this
True or
is tricky.
false? True or false?
Wait, before you say that, let me do this. 0 plus 0 minus 25 is negative 25. Now be careful, because you have these absolute value bars. You don't just have negative 25 is greater than 5. If that's it, it'd be false. But you've got to take the absolute value. What's the absolute value of negative 25? 25. So now,
True or false?
true or false?
It's gonna be true.
Yeah,
True.
that's true. So shade. And I know the rest of them. False, true. It alternates. False.
So knowing what you know about repeated factors, that really helps you with the checking. You don't have to 1, 2, 3, 4. There were 5 intervals. We only had to check one of the 5 intervals to figure out what was happening everywhere else. So final step. What do we need to do? Interval notation. There are 3 intervals. Call it out as if you were typing it in. What would you type first? Parentheses. Are we going to have any brackets? No, because there are no closed circles. So parentheses, negative infinity. What goes after the negative infinity?
-6.
No, before the negative 6. You got to
She got
type
ahead.
that comma.
Comma.
You got ahead of us.
Negative 6.
Close the parentheses. Or, yes,
Parentheses.
Parentheses.
-5.
Negative 5.
-4.
Comma 4. Parentheses.
I think this is the first one we've done with 3 intervals to type in. Okay.
Parentheses.
Parentheses.
5, infinity.
5, comma infinity.
Parentheses.
Now,
Any questions there?
okay. A word of warning. If you're a viewing example person,
Oh, Lord.
I highly discourage that. As teachers, we can turn off the viewing example, and I'm always tempted to, but I never do.
But for this stuff,
But this assignment, I'm really, maybe I should have turned off the viewing example. And if you're wondering why, well, instead of doing this, what we did here,
they think about it.
well, and they also, they come up with something. Oh, wait.
I think-
negative 5 to 4, and then 5 to infinity.
Yeah.
Let's look at what they're doing. They're trying, I don't know.
Tony, wait a minute. Oh, wait a minute. Now they want us to choose the correct graph.
Huh.
Oh, and they're not putting parentheses and brackets.
No, open and
I mean,
closed
open and
circles.
closed circles.
But which one of these is the graph? that
Instead,
we-
in place of an open circle, they're putting a parenthesis at the number. In place of a closed circle, they're putting an actual bracket at the number. The problem with that is you got to face the things towards the shading. When you're labeling your cut points, do you know which direction you're going to be shading in?
Look, show my thing
Yeah.
here. When we were doing this, we didn't know at the time that it was going to be shaded that way. So if you're going to put the parentheses and brackets instead of open and closed circles, you sort of have to do the testing first. Okay? But go ahead. Oh,
So-
which one was it?
It's certainly not
B.
A or C.
It's B.
B,
It has
I
the
agree.
parentheses. And
Okay.
Now,
Hold
click
on.
viewing it. I want y'all
Before I do,
I know these are long problems, but they're doable. Okay? You can do it. Heck, if this is some of the longest stuff we'll be doing this semester. Okay? So If you have any questions, we'll try to answer them. Otherwise, we'll see you on Wednesday. Wednesday, we begin graphing, and most people consider Wednesday easier than today. Okay, so that's your pep talk. Okay, the next class will be easier. Okay, the next lesson.